So today I'll be talking about Latin square designs, a statistical tool used in experiments. So what is a Latin square? In an experiment with multiple factors, you may want to test various possible layouts of each factor. A Latin square is a type of experimental design that incorporates multiple test configurations. The actual layout of the square is a square, with n-squared number of cells. Ideally, we would want to avoid using smaller Latin squares because they would limit the number of degrees of freedom available. Pictured here are three permutations of the same square. Where do these Latin squares come from? Latin squares come from Euler, who utilized the Roman or Latin alphabet for the symbols of the squares, hence the name. A typical Latin square only takes one factor. Another type of square is the Latin Greco square, which takes two factors. Pictured here on the left is the single factor, and pictured on the right is the two factor, otherwise known as the Latin Greco square. Pictured here are two examples of Latin squares, Sudoku puzzles on the right, and agricultural crop layouts on the left. Crop layouts are a great real-world example for Latin square designs, as it is easy to relate the rows and columns of the table to the physical location of the crop group. In Latin Greco squares, the two variables being tested against location could be the pesticides and the fertilizer. We can transform a Latin square into a table and perform some statistical analyses on them. These tables have values populated in the cells. In this table, it's showing you that you can take the sums of the rows and the columns. This table takes it a step further. We can use the sums pulled from the rows and columns to find the mean of them. The mean of the whole table can also be calculated classically by summing the values in the cells and dividing by the number of cells. In summary, Latin squares were originally created by Euler as a type of statistical test for experiments. It's important to remember that the bigger the squares, the more degrees of freedom we'll have. We can populate the data from the squares into tables and classically perform statistical analyses on them in order to determine further results of the tests. Thank you for listening, and I hope you found this informative.